Good morning, all. Am I audible? Am I audible?
Yes, yes.
Yes.
Yes, Jay, you're audible.
Stephen Hawking once said that artificial intelligence is likely to be either the best or worst thing to happen to humanity. Very warm welcome to all the dignitaries and participants to this webinar. It's my immense pleasure to extend you a warm welcome on the behalf of Christ College of Engineering to this webinar on artificial intelligence, applications, effects, and ethics. Let's begin the section by evoking the blessing of Lord Almighty. Let's begin the section with silent prayer. Now, with utmost pleasure, let me invite Father John Palekara, our dynamic executive director, for welcoming this session. Father, please.
Yes. Very good morning, everybody. Respected Dr. John Thomas, today's resource person and chief guest of webinar, and respected VD John sir, our vice principal, respected HOD, Benny sir, and all the respected faculty members, and my dear young engineers. I am so happy to address you in this morning. As Joel was telling, this artificial intelligence, adding brain to machine can be a blessing or it can be a curse, depending on how we put, how we design, how we define. That makes the difference. We know the TNT, the invention of TNT was a blessing, but this TNT was used centuries for destroying many kingdoms, dynasties, and even many wars are happened because of the discovery of TNT. Artificial intelligence also very keenly to be studied, and we have to make use with a discriminatory power. We know for years, technocrats and scientists were doing research in this area where hazardous environment, dangerous environment and settings, machines can be used where human presence is very difficult. In the furnaces, in the boilers, in the chemical area, we can put robots or brain added machines. And that will be much useful for, and we can avoid many contingencies to the human beings. Now, this COVID pandemic made us to think more on artificial intelligence because infection is very, very common. And if we introduce machines to the brain, we can avoid many of the situations. And even in electrical generation, transmission, and in many, and again, the auditing of energy can be used with. Disbursement of energy can be used with machines. And in many of the advanced countries, substations or power stations are not controlled by human beings. And even the tower line, now for maintenance, human beings are getting involved with. Electrocution is a threat. But if we add machines and if we make wireless equipments, we can do the maintenance very easily. But again, we should be very careful where to, when to, how to, that we have to think about. And you people are very lucky to listen to a great personality, Dr. John Thomas. He's very young, maybe age of few people, but no, he attained many things with his hard work. He studied very reputed institutions in India. He went abroad and he pursued his doctorate and studies from famous university in Singapore, that is Nanyang Technological University, Singapore. And again, he's moving to Canada. I think we have to keep him as a role model and we have to get inspiration from him. And we are now going to make a journey with Dr. John Thomas. And Dr. John Thomas is now first cousin of our Needu Miss. So I thank Dr. John Thomas for finding out time to come forward and sharing your vast experience with the young engineers of our college and from different institute candidates. Thank you so much, Dr. John Thomas. We are much grateful to you. And our young engineers took this initiative, that is BETA, the professional body of our electrical department, the only initiator, with the blessing of HOD Professor Benny sir and Needu Miss and all the faculty are now behind inspiring our young engineers. And our student community only made all the publicity and all the arrangement and all the communication in this regard. So I congratulate Electrical and Electronics Department of Christ College of Engineering. And I especially thank our student community for making such an initiative. Once again, I wish you all the best, and let us think together and let us join together to make our country better, to make our globe a better environment to live with. May God bless you. Thank you so much. And again, from the bottom of my heart, thank Dr. John Thomas for coming over and inspiring our young engineers. I conclude. Thank you. Have a blessed day. May God bless you.
Thank you, Father. Thank you so much. And now, let me give a brief intro about today's resource person, Dr. John Thomas. He completed his undergraduate studies at NIT Calicut in 2014, and in 2015, he was offered the Graduate Research Scholarship funding to pursue PhD at School of Electrical and Electronic Engineering, NTU University in Singapore. His research was focused on developing an artificial intelligence-based system to detect brain disorder without human interventions. Hearty welcome to our Christ family, sir. And our guest to know about Christ family, let me give a brief intro. Christ family is the one among the top-ranked engineering college in Kerala, established in 2015. CCE has achieved great height and still climbing the ladders of success with the help of dynamic executive director Father John Palekara, exuberant joint director Father Joy Payapalli, the bold-time supporter Dr. Sajeev John sir, courageous vice principal Dr. V.D. John sir, a bunch of passionate faculties and loving students. So welcome Mr. John Thomas to our Christ family. I would like to thank all of you for taking the time out of your heavy schedules and marking these hours with your glorious presence. Now, let's begin the section. So let me invite Dr. John Thomas for the webinar. Welcome, sir.
Hello. Good morning, guys. Am I audible at the end?
Yes, sir. Yes, sir. You're audible.
Okay. So let me get my slides up. Hold on a second. Okay, there you go. Are my slides visible? Can anybody check?
Yes, sir. It's visible. It's visible.
Okay, just hold on a second. Yeah, there you go. So first of all, thanks Father John for your hearty felicitation. I'm John Thomas from NTU Singapore. So today I'll be giving a talk about AI applications, effects, and ethics. So please consider this as a discussion session rather than a one-sided lecture. So feel free to interrupt me at any point of time if you are having any questions. Also, you could add your comments and suggestions too. Also, the coordinators, please note that if the slide or the video or something happens in between, just let me know. You can just interrupt me at any time. Since it's an online platform, sometimes it could be tricky. So let's get started. So let's say uh, you came across a new word or a new concept, and we would like to more about it. So what do we do? Just like anybody does, we just Google it. So I have given the example of the keyword artificial intelligence as an example. So here, as soon as you type in artificial intelligence, the Google search bar will give you a lot of suggestions. So here there are more than 10 suggestions. And once you click on one of the suggestion, it will direct you to a lot of web pages with information. So that's the Google Search Assistant AI. So artificial intelligence, or in short AI, refers to programming machines to think or act like humans. So the AI algorithms have been developed by the humans to aid them in many tasks. So the AI system typically consists of three main parts. The algorithms, it contains the code for implementation and design of the AI systems. Then mathematics, all the algorithms of AI are based on mathematics. But the funny part is, even without knowing any of the mathematics, nowadays you can actually create a big sophisticated AI system. That's the thing. And finally, the mechanical components. So if we say AI, so the first picture that comes to your mind is a robot with all the mechanical hands and doing all the action as in the movies. So this is not the case. So AI can be something as simple as a calculator, or it could be something like a simple program which you have created in your computer. So now let's look at how AI enables a machine to act intelligently to help humans. So it is a three-step process: adapt, reason, and solution. So let me try to explain this with an example of an autonomous car or a car driven by a robot. So let's assume we are trying to teach the system to obey the traffic rules. So traffic rules in the sense, so if it's red light, the car has to stop. If it's green light, the car has to move. So that's the simple procedure we are trying to teach the car. So in the adapt phase, we are giving the inputs to the system. Okay, red light, stop, green light, move. And in the second reasoning phase, the AI creates a structure in its brain to study this pattern: red light, green light, and what is the action to be performed during that time. And as an outcome of the solution, when a red light comes, the AI applies brake, and when it's green light, it applies the accelerator pedal. So this is how AI modifies a system to perform like humans. So now let me introduce two particular words. So when we say AI, you will come across two major words: machine
Excuse me,
learning
sir.
and deep learning. Yeah,
Excuse me, sir. Sorry for the interruption.
yeah, sure.
Sir, can you please enlarge the screen?
Come again?
PPT presentation. Can you please enlarge it?
Okay. Just one second. Um, okay. Sorry. I think it's to stop sharing. It's, okay. Sorry. Not sure. Is it up now? Hello?
Yes, sir.
Is it full screen?
Yeah, now it's okay then. Can you please? something.
Hold on. Yeah.
Yeah, it's okay now, sir. So good.
Okay. Yeah.
Okay.
So let's continue. So when we talk about AI, there are two main words which comes up. It's machine learning and deep learning. So machine learning and deep learning are advanced tools in AI that are inspired by the human brain. So AI refers to the whole bunch of codes or programming of all the machines, even the simplest of the calculators, to help humans. But AI and machine learning and deep learning are just subsets of AI. So just to give an intro. So now moving on to the classification of AI. So AI can be classified broadly into three: weak AI, general AI, and strong AI. So all the AI which we have today in the world are weak AIs. So the example starts from the simplest of the calculators to the face recognition and fingerprint sensors in your mobile phones, the chatbots which we use in our social media, and the Google search assistant, as I told you before, and all the humanoid robots, and even the sophisticated systems of Siri, the Google Assistant, and Amazon Alexa. All these are examples of common AI. So these, why we call them as weak AIs, is that so these systems are programmed to perform a particular tasks. They cannot perform like a complete human, but they can only do a particular part of a humans. Now, when we talk about general AI, it refers to an intelligence which can perform similar to humans. So, similar to humans means it should have the vision, it should have the ability to think, and it can do all the things that a human being can do. So, that's a general AI. So, now when we come to a strong AI, it should be capable of performing better than a human intelligence. So a general AI or a strong AI is still a fiction, but I think you might have seen such systems in movies. So, for example, the all the robots in the Terminator movie series are strong AIs. Similarly, if you have watched, I think most of you might have watched the Avengers movie. So, the Ultron in the Avengers movie is again a strong AI. So these kind of AI, the general or the strong AI, will have emotions and and independent thinking. So now moving on to the applications of AI. So the common application of AI is robots. So nowadays we see robots in many applications such as surgery, in restaurants, and in many other places. The second application is autonomous cars. So in US, that company called Tesla is currently developing an autonomous cars which can drive by its own. And in my university, we are currently doing a trial of a automated bus around the campus. So the project is hopefully like it will be launched soon, probably in the next quarter. And the next is social media. So I don't need to introduce you to social media. So all the social media sites, especially the search engines, the suggestions, the video suggestions, the friend suggestion, everything works on AI-based systems. So then we have security and surveillance. So the fingerprint sensors on your phone, the face recognition systems, the bank surveillance systems, etc. All are examples of security and surveillance. And finally, AI has its applications in healthcare as well. So this is an example where our respected PM was inaugurating a artificial robot in Reliance Hospital, Mumbai. So um, this robot is capable of performing a artificial urology surgery by its own. But it needs a little bit of human interference, but still it can do the work. So if you want to know more about it, you can check the link below. It has the complete news. So in general, AI is everywhere in our day-to-day lives. So since we are in the almost in the lockdown phase, or like we are working from home and attending classes from home, we on a day-to-day basis we are using AI in some or other applications. Even the platform which we are using for the webinar, the Google Meet, it's also a AI-based platform. So now moving on. So every technology has its advantages and disadvantages, and so does AI. So let's first discuss the advantages of AI. So the primary advantage is automation, reliability, and efficiency. So since we are programming the system, we can decide the precision at which the system should work. So this can promote faster decisions, less human error, and the AI typically never gets bored or tired. It can work 24/7. We just need to recharge it. Secondly, all the AI codes and algorithms are open source nowadays. So that means we can easily create and deploy a AI model. So that's the reason why we are having a lot of AI based startups in nowadays. Now, thirdly, the solutions are derived from the data. So since it's derived from the data, the solutions are more optimal as well as more reliable. And finally, AI makes life so much easier. So I think currently in the current modern world, we cannot live without AI. So now let's go to the disadvantages of AI. So the primary disadvantage of AI is the understanding or explainability of AI. So this means that so we are able to develop an AI system, but we do not understand what an AI does or how does it learn completely. So in technical terms, we still call the AI as a black box. So the simpler AI systems I mentioned, like the calculators, we can understand. Okay, if you press the plus button, it means it does addition. But if you go to face recognition systems or autonomous cars, we don't know what the AI is learning. The AI gives a high performance, but we don't know what features or how the AI learns it. So that's the explainability. Secondly, the performance of AI is predominantly dependent on the quality and quantity of data. So if we have high quality data, the efficiency of the AI system will be high. But in the real world, the size and quality of the data set, especially the healthcare based data sets, are very low. So still, we are in a process of getting more data. So maybe in the next 10 to 20 years, we might be capable of building super efficient AIs. So nextly, we just have a few specialists who actually understands AI and who can actually deploy systems based on AI. And the next one is unemployment. So this is one of the most feared effect of AI. So since an AI can work 24/7 without getting bored or tired, all the repetitive and all the boring jobs, I would say, will be taken up by the AIs in the next 5 years. So this is kind of a warning for everyone, especially the engineers. You need to upskill yourselves, and you should be the ones who are developing these platforms rather than working in routine jobs. And finally, we have the ethical concerns, which is a relatively a modern topic. So I'll discuss about this towards the end of the slides. Moving on. So till now, I told you about what is an AI and the applications of AI. So now let's look at how can we train an AI, or how does an AI learn. So I have taken the example of a deep learning technique referred to as convolutional neural network, or we can, in short, we can call them as CNN. So a CNN is widely applied for object detection and image processing technique, similar to the face recognition system in our mobile phones. So as I mentioned, deep learning is an AI function. It is one of the modern functions that is inspired from the human brain. So now let's look at how a baby learns to classify objects. So for simplicity, I have taken two objects, a dog and a car. So how does a baby learn to distinguish between a dog and a car? So when we were children, or when we were a baby, our parents will teach us. When we will have the visual input of a dog and a car, and our parents will teach us, okay, this is a dog, this is a car. And similarly, when we reach our preschool and higher standards like first standard or second standard, our teachers will be teaching us a lot of objects and even a dog and a car. So by seeing these pictures and by getting the feedback from our teachers and parents, we create a network in our brain to distinguish dogs and cars. So how do we learn it? We still don't know. So that is again an open question. So that we won't be discussing it here. So that is related to neuroscience studies. So anyway, our brain creates some structures to distinguish dogs and cars. It's exactly the same way how you train a network. So if you want to classify dogs versus cars, we take a lot of images of dogs, we take lots of images of cars, we feed it into a deep learning technique. So here I'm using convolutional neural network. So we'll feed those images into the algorithm and we'll just train the algorithm to develop an object identification system. So the procedure is almost similar to that of humans. And once we have the object detection system, when a new image of a car comes, the system will say, okay, hey, that's a car. So that's how a CNN works. So now let's look into a little bit more in depth to CNN. So what does a CNN learn, or how does it learn? So let's take an example of a car. So a CNN typically consists of three sets of layers: convolutional layer, subsampling layer, and a fully connected layer. So these are a little bit technical terms. You might or might not want to know it, but still, I'm just giving you an overview of the whole system. So you just need to understand that there are three types of layers in a CNN. That's it. So if you take an image of a car, the first convolutional layer actually creates a lot of images of a car. So you can see it as see it as something like, so you are seeing the car from different angles. So you can see the car from the front view, from the sides, from the top, etc. So the convolutional layer creates multiple viewpoints of the same car, and then so it can generate up to millions of images of the same car, and these can be called as features. So since a lot of images are generated, we need to reduce the dimensions. So the subsampling layer takes the input from the convolutional layer, reduces the dimension, and supplies it to the fully connected layer. And in the fully connected layer, the learning actually happens, and we get an output that this image is of a car. So that's how the learning happens. So the important concept here is, what does a CNN learn? So the structure is not important, but to know what does a CNN learn is important. So let's consider a simple CNN with three sets of layers. So I have represented three layers, and the CNN is trying to learn an image of a car. So if you look at the lower level features, you can see it is trying to learn some color patterns and some horizontal and vertical lines. As we go up the feature level, so you can see it is trying to learn some circular edges, some combinations of edges, lines, some combinations of colors, etc. And even if you go to a higher level, you can see that it is kind of learning some parts of the wheel, some parts of the mirror, etc. So it typically represents a human way of learning. So in a sense, like, so if we are asked to distinguish between a dog and a car, one obvious difference is that the car has wheels. So when we try to understand CNN, we can see that it is trying to imitate a human, similar to it, but still we cannot make out, like, okay, so we saw a part of a wheel in the feature base, but we still don't know exactly what it is learning. So in conclusion, a CNN can perform on par with humans, but the explainability is still an open question. And this is the most concerning part. So here it is okay. So we don't need to know, okay, what an AI is learning. But in a different scenario, this could be troublesome. So I'll get to it towards the end of it. So now I am getting to explain my work in Singapore. So my work in Singapore was mainly focused on AI for healthcare. So So AI can help in healthcare in mainly four ways. So the first one is in training and research. So if we have a database of the history of patients or how they were diagnosed, we can use this information to teach the new doctors to identify such diseases, as well as this also could be used to develop new surgical or diagnostic procedures. So the second portion is the keeping well. So this mainly refers to gadgets such as Fitbits, Apple Watch, and all the monitoring devices. So it's the typical example is the monitoring of your heartbeat, the number of steps you walked in a day, etc. And then we have robotics. Robotics mainly aids for surgery, monitoring, diagnosis, etc. And the next one, the diagnosis and monitoring and decision making. So that's where my research focuses on. So my research focuses on a brain disorder referred to as epilepsy. So epilepsy is the fourth most common brain disorder in the world, and it affects approximately 70 million people in the world. So for epilepsy, AI can aid the detection and surgery of epilepsy in two ways. So the first part is the diagnosis part. So we can use AI to detect or monitor epileptiform patterns in electroencephalogram or the EEG. So I'll talk about EEG in the next slide. And then AI could be also used for pre-surgical planning. So, once we are diagnosed with epilepsy, so the doctor will be prescribing you medicines as the treatment. So at least 50% of the patients who are epileptic do not respond to medications. So in that situations, only epilepsy surgery is the key to get you epilepsy freedom. So therefore, we can also use the AI system to predict which portion of the brain has to be removed in order to remove epilepsy. So those are two of my works. So I'll give you a little bit more in-depth details of my work. So let's discuss about EEG. I think most of you might be familiar with ECG or electrocardiogram. So that is a recording of your heart signals. Similarly, EEG is the recording of your brain signals. So it is typically recorded by placing electrodes on your skull, and this is the top view of the electrodes, and each electrode has its own name. So nasion refers to your nose. So the two electrodes, FP1 and FP2, are the electrodes which are nearer to your forehead, and each electrode has its own name. And an EEG typically looks like the figure on the right. So each channel, and it is like a waveform. And for your observation, I have actually annotated a few of the epileptiform patterns. So we collectively call these patterns as indirectal epileptiform discharges, or IEDs. So it typically looks like a spike. So now let's look at how the doctors diagnose epilepsy. So when you go to a hospital to diagnose a brain disorder, so the doctor usually prescribes a 30-minute EEG recording. So they will put electrodes on your head, and you have to stay still for around 30 minutes, and they'll get your EEG recording. So once the recording is completed, the doctor actually goes through the EEG recording, the whole 30-minute EEG recording, to find such epileptiform patterns. And once they find such patterns, they will provide treatment to you. They will probably prescribe a few medications. And so this is kind of a tedious task. Like the doctor has to monitor the recordings for longer hours, and it's kind of boring. So, and a doctor typically takes about 10 minutes to review a 30-minute EEG recording. So this procedure could be automated. So the significance of automation is that in a developing country like India, there are a lot of patients, and the number of experienced doctors are very less. So if a doctor has to spend like 30 minutes on the EEG recording, 10 minutes on the diagnostic procedure, and then more time to prescribe treatment, it is a chaos. It takes a long time. So that's why we developed an automated system based on AI to detect such epileptiform patterns. So this is an illustration of a AI-based IED detector which I developed during my PhD studies. So the link to the publication is given at the bottom. So if you want to know more about it, you can refer to it. So this is so here I have illustrated all the block diagrams involved in the whole system, but you don't need to worry about the different systems. So I'll get to the main points. So similar to the example where I showed we trained a CNN to distinguish dogs and cars. So here we extracted the EEG patterns. So we extracted the positive EEG patterns or the epileptiform patterns. They are shown in red. And we also created a set of non-IEDs or the background waveforms. And using these examples, we trained an AI system. So here we also used a CNN to do the same thing. And once we trained the AI system, we got an IED detector which can actually detect patterns in EEG with high efficiency. So the best advantage of this technique is that it can diagnose a 30-minute EEG recording in just 1 second. So previously, what took about 10 minutes for the doctors to evaluate, it just takes just a second to do the processing, and this makes a huge difference. So I have almost completed my studies in Singapore, and I'll be moving to McGill University in a few months. And the project proposed over there is the prediction of the portion of the brain that has to be surgically removed. So I can give you an overview of the project. It is yet to be done. So the project aim is similar. So here it's not about diagnostics, it's about predicting the portion of the brain that has to be removed. So similar to our diagnostic system, we use the EEG data, we develop an AI model, and the AI model has to predict the portion of the brain that has to be removed in order to get epilepsy freedom. So that's a future work. So now moving on to the challenges of AI. So the first challenge is transformation. So the transformation has already happened, or it is happening. So all the repetitive jobs and the routine jobs will be taken up by the robots. So it's time to upskill yourselves. So the second point is misinformation. So this misinformation has is very relevant, especially in this time where we are having a pandemic. So every day you might be getting a lot of forwarded messages in your Facebook or WhatsApp. So according to a study done by Twitter, fake news travels 6 times faster than truth. So that means if you get 7 news items, 6 of them could be fake. And since it is more related to human psychology, so we would like to read about gossips rather than facts. So if you are getting a WhatsApp message, so don't just forward it to your friends. Just take some time to think about it and just check whether if it's the truth. And the next is privacy. So I think most of us are using at least one of the social media sites. And while installing a social media site, we are giving our acceptance or agreement to the company that you can keep some of our private data. And addiction and depression. So this is mainly attributed towards the excessive use of social media sites. And the next point is regarding inequality and bias. So this could deal with racial bias, gender bias, and a caste bias or religion bias. It could be anything. So a recent example is it was quoted by Forbes. I have given the link here. So what happened was the Google Photos AI, they actually tagged 2 African American as gorillas. They didn't tag them as humans, but animals. So an AI, since it's a technology trained by humans, they are also not free from inequality or bias. So the performance of an AI in terms of bias mainly depends on who trains the system as well as what data has been used for the training. Now moving to the final point, it's regarding social acceptance. So this is again an upcoming field. you need to think about it now because the machines are going to take over soon. So the first thing is regarding, so I'll give you two examples. You can just think about it. So the first portion is, okay, you are booking an Uber or a taxi, and an autonomous vehicle or a car which is driven by a robot is coming. So will you trust the robot, or will you be comfortable traveling in that car? Now, as a second example, so it's related to healthcare diagnostic systems. So we faced it during like the deployment of my system. So so let's say you are going to a hospital to have a diagnosis. So once you enter the doctor's cabin, you see a robot like taking a temperature and prescribing your medicines. So will you be okay with a robot doctor? So these are things you need to think about. It's more about the human psychology. It's about social acceptance. And now moving to the ethics part. So before jumping into ethics, let me coin a few terms. So the first one is singularity. So singularity is defined as the point at which technology growth or the AI intelligence surpasses human ability. So some experts have predicted it to be 2030. But the significance of the singularity point is that so after this point, the AI can lead to human existence. So that's a prediction. It might or might not happen. Now the second thing is about collective data. So even during my college days, I used to think about something like, okay, so people, we are all aware of the fact that all the social media platforms record our private data. But I used to think, okay, does my individual data has any value? So many of you might have the same thought, like, does an individual data have value? So the individual data as such doesn't have any significance, but the collective data does. So let me give you an example with the functioning of Google Maps. I think mostly all of you might have used the app. So it is a map that helps you to navigate from a place A to place B. So you just need to key in the location which you want to go and give your location, and the app will give you a route, or it will optimize the route, and it will show the different traffic congestion in that area. So it typically has three sets of colors. The blue means there is no traffic, red means it is completely congested, and yellow means it's moderately congested. So this like evaluation it's a live updation. So let's look at how it happens. So let's assume you are stuck in the traffic. You might be using Google Maps, or you might be using any other social media platforms to do something while you are stuck in the traffic. So this information is with the Google Maps. So your individual information doesn't have any significance. But when Google Maps sees it, so there are a lot of vehicles which are stuck at a point, and these vehicles were moving maybe a few minutes back. So from this, it can derive that at that particular location at which the vehicles are standing still, there is heavy traffic. So they'll update in their system that particular location there is heavy traffic, and they'll change that route to red. So that's how it happens. So this illustrates the importance of collective data. So don't think your individual data is not valuable. So you need to still protect it. So this is one positive example of collective data, but there could be a lot of negative effects such as polarization, violence, and there are a lot of problems, political problems as well. So now moving to the dilemma. So this is again a relatively newer concept. So I'll try to explain this by the effect of AI in social media. So initially, AI systems were developed as a tool to aid humans. So it was considered as a tool. But nowadays, so let's take the example of the Google search engine. As soon as you key in the word artificial intelligence, the system takes your keywords as input, or you can say it's a feedback, and it gives you suggestions. So you key in the next keyword, and then it takes that as the feedback and it will give you another suggestion. So if you consider the terminology tool, a tool does not take feedback from you, or it does not take something from you. So all the AI engines, they are taking something from you and they are kind of trying to give you a suggestion. So this is not a bad thing, but what I am trying to convey is that social media platforms are not tools. They are like a reinforcement learning mechanism which is capable of manipulating you. So previously, as I mentioned, most like our private data is in the social media platforms. So they know the videos which we have watched, our interests, the movies we have searched for, all your search keywords, the posts you have shared, the posts you have liked. So it typically represents your mentality. So in the virtual world of the social media, there is a virtual you and me. So we all have a virtual brain or a virtual representation in the social media platform. So this is again, it's not bad. It helps us to get suggestions, recommendations, etc. So now let's get to the villain of the story. So the problem is mainly caused by the business models adopted by these social media platforms, or collectively we can call them as corporates. So their business model is only motivated towards profit or revenue. So we are all using the social media platforms for free. So and then the corporates have to generate revenue from some source. So their revenue comes from ads. So the more ads we watch on social media websites, the more revenue they will get. So their business model is simple. So the in as per the legal terms, they cannot share our private data, but then they can use our private data to give us a better service. So for this, what they are doing is they are taking our private data, they are giving it to an AI system, and we are telling the AI system, okay, so you can use the private data. You have to optimize your system, and so such that we will get more revenue. Or in other terms, you have to get people addicted to such platforms. So that's the business model they are following. So I'll highlight the main issues with this. So since the AI is modeled to get us occupied on the social media platforms, it can lead to addiction, depression, etc. So this happens mainly in the newer generations, maybe 1996 or above. So we need to be aware of the situation. And the next point is a polarization of or violence. So currently in the social media sites, we do not have a filtering mechanism or a supervisory mechanism to filter out the fake news. And as I have mentioned previously, fake news spreads faster than the truth. And the AI system which is deployed in the social media website, they cannot classify a news as a fake news or the truth. So the only thing they do is, okay, they'll see if people are interested in a particular video or news, and they'll just push the news up, or they'll increase the rating of the news. So that can lead to polarization, violence, that can even control the mentality of people. So next, moving to the next point, it's explainability. So as I explained in the context of classifying whether it's a dog or a car, we have a general understanding of how AI works, but we still don't know what it learns or how it learns. There is no clear picture. Even the engineers or the software engineers in Google or Facebook, they also doesn't know what an AI actually does. And next point is accountability. So if, as I mentioned just now, if a corporate uses our private data, they can be sued under legal terms. But since they are just giving it to a machine, to learn about it, and they don't care about what the machine learns. There is nothing which we can do against them, and the corporates do not they are not accountable for what is happening due to the AI. And the worst part is we cannot shut them down. It is due to mainly two reasons. So the first reason is nowadays we cannot live without AI based technology, especially the platforms such as Google, Facebook, Instagram, etc. And the next point is these are large corporates. They are even bigger than a lot of governments. So to bring them down, a revolution has to happen. So if you want to know more about dilemma, you can actually look it up at the Center for Human Technology. That's a new center which are opened by expats from Facebook and Google who want to educate people about this dilemma and try to find a solution. So I have given the names at the bottom. Also, if you regularly watch movies, there is a new movie referred to as The Social Dilemma in Netflix. I think it was released last week. It gives a real good interpretation of the dilemma. You can just look it up. Now, let's look at what can be done from our side. So, as responsible citizens and the next generation, what can be done? So the first thing is awareness. So we need to recognize the problem. We need to educate our peers and family, and we should be open to discussions in such problems. The second thing is, so we are all educated. So when we see a news or when we are trying to share a news, we should check for the facts and truths before conveying an information. So that should come from our side. Next is, as engineers, we should be responsible. I think few of you might be developing AI systems in future, or a few of you might be working with Google or the big companies in future. So you need to be responsible on what you are creating. And finally, this is more about the society as a whole, or the government has to do it. So there should be some regulations or accountability, governance, and rules to control these AI platforms. So now there is a exciting tool online. It is referred to as the moral machine. It is developed by Massachusetts Institute of Technology. If you just Google it, you can find it out. So this is a typical example of the human judgment towards self-driving cars. So, or you can typically say an AI system. So it's an interesting procedure. You can just look it up. So now moving to some resources. If some of you might be interested in this stuff. Um, AI still has a lot of open questions and a lot of opportunities worldwide. So you can search for any opportunities. It's a really interesting field nowadays. And if you want to learn more about AI, I would recommend a course. It's referred to as deeplearning.ai. It's available on Coursera. And if some of you are interested to develop an AI system, I would recommend two platforms: TensorFlow, it's by Google, and PyTorch. It belongs to Facebook. So these two are the best platforms available today, and these are open source as well. So in my research, I was mainly focusing on TensorFlow since it was easier to deploy products based on the software. And if some of you are looking for internships or projects, you can look up the NTU India Connect program. So this is a program between my university and the different universities in India. So anybody can apply for this internship, and it's kind of a paid internship. You can just look it up online for the more details. And finally, thanks to all the people who have attended the webinar, and thanks to the faculty and others and the student coordinators at Christ College for hosting me. So this is my entire team at Singapore. So this was taken during Stratcom APAC 2019. So this was a workshop conducted by our team to discuss the impact of misinformation on social media. That's it. So now I am open to questions. So please feel free to ask about anything and in any language. I'll try to answer like to the best of my knowledge. Thank you. Yeah. Hello. Hello.
Hello, am I audible?
Yeah.
Yeah, if we need to study artificial intelligence, do we need any basic knowledge in any other areas?
Um, so that's why I told it depends on you. So as engineers, I would recommend you need to learn about the basics, especially mathematics, to deploy an AI system. And you should also consider the ethical problems, as I mentioned towards the end, the accountability, ethical problems, and you should create the system responsibly. But if you are somebody like, okay, if you're working in a company and the motive is just to create a system, you don't need to know any of the mathematics. You can just use the platform, learn how to use the platform and create an AI model. But if you want to go into a research area, more like developing a new algorithm for AI, you definitely need to learn about mathematics. I hope that clears your question.
Yeah, thank you.
Shall I ask in Malayalam, Dr. John?
Yeah.
Shall I
Go.
ask in Malayalam?
Yeah, sure.
ഇത് മെഡിക്കൽ ഇപ്പൊ എഞ്ചിനീയറിംഗ് സ്റ്റുഡൻസിനെ സംബന്ധിച്ചിട്ട് അല്ലെങ്കിൽ എഞ്ചിനീയറിംഗ് കഴിഞ്ഞ ആളുകളെ സംബന്ധിച്ചിട്ട് ഈ ആർട്ടിഫിഷ്യൽ ഇന്റലിജൻസ് കുറെ കൂടി അറിയാൻ പറ്റും. പക്ഷെ ഇത് മെഡിക്കൽ സ്റ്റുഡൻസ് അല്ലെങ്കിൽ ഒരു ഡോക്ടറെ സംബന്ധിച്ചിട്ട് ഹൗ ഇറ്റ് ഈസ് വർക്ക്?
ഓക്കെ, അപ്പം I'll get it in Malayalam as well, that's easier. അപ്പോൾ ഇതൊരു സീരിയസ് ടോപ്പിക് ആണ്. ഇപ്പൊ എന്റെ എക്സ്പീരിയൻസിൽ ഇപ്പൊ എന്റെ PhD ടൈമില് ഞാൻ ഒരു ഡോക്ടറെ റീപ്ലേസ് ചെയ്യുന്ന സിസ്റ്റം അല്ലെങ്കിൽ ഒരു ആർട്ടിഫിഷ്യൽ ഡോക്ടറെയാണ് ഉണ്ടാക്കിയത്. അപ്പോൾ ഇത് ഈ ഇങ്ങനെ ഒരു സിസ്റ്റം എടുത്തിട്ട് നമ്മളൊരു ഹോസ്പിറ്റലിൽ കൊണ്ടുപോകുമ്പോൾ ഡോക്ടർമാർക്ക് അവരുടെ കൺസേൺസ് ഉണ്ടായിരിക്കും. ഓക്കെ, ഈ സിസ്റ്റം വന്നു കഴിഞ്ഞാൽ ഞങ്ങളുടെ ജോലി പോവുമല്ലോ. അപ്പോ അതൊരു ഭയങ്കര കൺസേൺ ആണ്. അപ്പൊ അതാണ് മെയിൻ തിങ്. സോ അതുകൊണ്ട് സോഷ്യലി ഇതിനൊരു ആക്സെപ്റ്റൻസ് വരാൻ കുറച്ച് ടൈം പിടിക്കും. ഇത് ഒരു സോഷ്യൽ ആക്സെപ്റ്റൻസിന്റെ പാർട്ട്. ഇനി ഇതിന്റെ എക്സ്പ്ലെയിനബിലിറ്റിയുടെ പാർട്ട് ഉണ്ട്. എക്സ്പ്ലെയിനബിലിറ്റി എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഞാൻ പറഞ്ഞ പോലെ AI സിസ്റ്റം എന്താണ് ചെയ്യുന്നതെന്ന് നമുക്ക് കംപ്ലീറ്റ് ആയിട്ട് അറിയില്ല. നമുക്കൊരു ജനറൽ അണ്ടർസ്റ്റാൻഡിങ് ഉണ്ട്, പക്ഷെ എന്നാലും കൃത്യം എന്താണ് പഠിക്കുന്നത് എന്ന് നമുക്കറിയില്ല. ഇപ്പൊ നമ്മള് ഒരു ഹോസ്പിറ്റലില് ഒരു ബ്രെയിനിന്റെ അസുഖം ഡിറ്റക്ട് ചെയ്യാൻ ഡയഗ്നോസ് ചെയ്യാൻ പോവുകയാണെങ്കിൽ, അല്ലെങ്കിൽ ക്യാൻസർ ഡയഗ്നോസ് ചെയ്യാൻ പോവുകയാണെങ്കിൽ ഡോക്ടർമാർ റിപ്പോർട്ടൊക്കെ പഠിക്കും. എന്നിട്ട് അവർ നോക്കും, ഓക്കെ, ഇന്ന കാരണം കൊണ്ട് നിങ്ങളുടെ ഇന്ന റിപ്പോർട്ടിൽ ഇങ്ങനെ ഒരു സാധനം കണ്ടതുകൊണ്ട് നിങ്ങൾക്ക് ഒരു പർട്ടിക്കുലർ ഡിസീസ് ഉണ്ട്. അങ്ങനെയാണ് അവര് ഇപ്പൊ പ്രെഡിക്റ്റ് ചെയ്യുന്നത്. പക്ഷെ ഇപ്പോ നമ്മള് ഈ ഡേറ്റയൊക്കെ എടുത്തിട്ട് നമ്മളൊരു സിസ്റ്റം ഉണ്ടാക്കി കഴിഞ്ഞപ്പോ സിസ്റ്റം പ്രെഡിക്റ്റ് ചെയ്തു, ഓക്കെ, ഇപ്പോ ഈ പർട്ടിക്കുലർ രോഗിക്ക് ഇന്ന അസുഖം ഉണ്ടെന്ന് ഇത് പ്രെഡിക്റ്റ് ചെയ്തു. അതിന് ചിലപ്പോൾ 100% ആക്യുറസി കിട്ടിയേക്കാം. പക്ഷെ ഇപ്പോ നമുക്ക് ഇത് പ്രൂവ് ചെയ്യാൻ പറ്റിയില്ലെങ്കിൽ, അതായത് എന്താണ് ഇത് ഈ സിസ്റ്റം പഠിക്കുന്നതെന്ന് നമുക്ക് ആ ഡോക്ടർമാരോടും ഈ പബ്ലിക്കിനോടും നമുക്ക് എക്സ്പ്ലെയിൻ ചെയ്യാൻ പറ്റിയില്ലെങ്കിൽ ഈ സിസ്റ്റത്തെ ആരും വിശ്വസിക്കില്ല. അപ്പൊ ആ വിശ്വാസ്യത കിട്ടാൻ നമുക്ക് ഇത് എന്താ ചെയ്യുന്നതെന്ന് പഠിച്ചേ പറ്റൂ. പിന്നെ ഡോക്ടർമാരെ സംബന്ധിച്ചിടത്തോളം നമ്മുടെ നാട്ടില് ഒരു കൺസെപ്റ്റ് എന്ന് വെച്ച് കഴിഞ്ഞാൽ ഡോക്ടർമാരെന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ അവർ പ്യുവർലി ഒരു ഹോസ്പിറ്റൽ എൻവയോൺമെന്റിൽ വർക്ക് ചെയ്യുന്നവരായിരിക്കും. അപ്പൊ അവർക്ക് ഈ ആർട്ടിഫിഷ്യൽ ഇന്റലിജൻസ് എന്താണെന്നോ അല്ലെങ്കിൽ എഞ്ചിനീയറിംഗ് എന്താന്ന് പോലും അവർ അറിയേണ്ട കാര്യമില്ല. പിന്നെ അവര് ഇപ്പൊ ഒരു ഹോസ്പിറ്റലാണെങ്കിൽ മേ ബി ഇങ്ങനത്തെ വല്ല സോഫ്റ്റ്വെയർ ഒക്കെ ഉണ്ടെങ്കിൽ അത് ചെയ്യാൻ അതിൻ്റെതായ ടെക്നീഷ്യൻസ് ഉണ്ടായിരിക്കും. സോ ഇത് നമ്മുടെ ഇന്ത്യയിലത്തെ കേസ് മാത്രമാണ്. പക്ഷെ പുറമേ നോക്കി കഴിഞ്ഞാൽ ഇപ്പൊ അമേരിക്കയിലും ഇപ്പൊ സിംഗപ്പൂർ തന്നെ ഡോക്ടർമാര് റിസർച്ച് ചെയ്തോളണം. അപ്പോ ഒരു 50%, അപ്പോ പകുതി ടൈം അവർ വർക്ക് ചെയ്യുന്ന പകുതി സമയം അവര് ഇങ്ങനത്തെ സിസ്റ്റമുകളൊക്കെ പഠിച്ചോളണം. അതുപോലെ തന്നെ അവരിങ്ങനെ പേപ്പറുകളൊക്കെ പബ്ലിഷ് ചെയ്തോളണം. അത് അവരുടെ ജോലിയിൽ പെട്ടതാണ്. അപ്പോ അവരത് പഠിക്കുകയും ചെയ്യും, കുറെ ഇങ്ങനെ പബ്ലിഷ് ചെയ്യുകയും ചെയ്യാറുണ്ട്. അപ്പൊ അത് ആ ചോദ്യത്തിന് ഉത്തരമായെന്ന് വിചാരിക്കുന്നു.
Okay, thank you, sir.
Yeah, okay.
Participants in the meeting can please ask questions.
So one YouTube
Hello,
comment.
sir.
So can AI solve that captcha messages?
Come again?
Can AI
Yeah.
solve those captcha that things?
Captcha.
Captcha. Yeah. That.
Captcha എന്ന് പറഞ്ഞാൽ let me check. Hold on. It's a comment in YouTube, right?
Yeah, sir.
Let me see. Look. Captcha. Let me check. Okay. So I think maybe most of you, I'll give you what is CAPTCHA. I'll give you the definition first. A CAPTCHA is a typical challenge response test used in computing to determine whether or not the user is human. Either it's the, so when you are doing some transactions or some logging in or something, so they'll check whether you are a robot or not. So can AI solve this problem? So it's difficult. So so CAPTCHA problem came up. So why do we need CAPTCHA? So CAPTCHA is like to prove you are not human. So so then why do you use AI to solve CAPTCHA? In other terms, I would say a CAPTCHA is developed to prove you are not a robot. And there are nowadays there are robots which actually can mimic humans and get past the CAPTCHA. So we need to create better systems to overcome better systems that can detect robots. CAPTCHA is not very reliable. So again, using AI to solve CAPTCHA, it's I don't know. That's I still don't know the answer. That's the thing.
Okay, so we have one more question from the YouTube,
Okay.
like that. Madhav Srinivasan K has asked, can you suggest an online platform by which I could learn AI part-time?
Yeah. So as I suggested in my slides, so the best two platforms to deploy or learn or implement an AI system is TensorFlow. That is the Google's platform, and then we have PyTorch. That's the platform by Facebook. So that those are two platforms, and they have a lot of tutorials, and they have I think they have some codes and all already given in their websites. You can just check it out, and you can also so if you want to learn more about it like a course, you can actually look into the Coursera course. It's called the deeplearning.ai. So that is the best course available as of now.
So,
Okay,
good morning here. I have a doubt.
Yeah. Yeah.
So
Go on.
regarding your PhD work, you had done a course, means you have done a project on healthcare. So,
Yeah.
and I just want to ask about regarding the success rate, means accountability when it compared with the normal doctor. Whether you are displaying the entire unit such that it can replace a doctor, whether you need any kind of sanctions from medical side
Yeah.
for
So
getting your project approved.
yeah. So I'll give you. So this challenge we had to face during my PhD studies. So currently my PhD project is patented and it's being developed into a commercial product. So in our first phase of clinical validation, so you have to actually do two uh, two confirmations. So the first, you have to do two studies to validate your system. So the first study will be to clinically validate your system. That is like you take your system to a hospital, you let the doctor diagnose independently, and then use the data and do the an evaluation again, and just compare how well your system performs with a doctor. So that is the first test you need to do. The second test is, so once you clinically validate your system, you need to get the approval from the like agency, the healthcare agency of the respective countries. So currently we have got the approval from the US FDA to deploy the system online. So in this, the second phase is more about paperwork and administrative tasks, and getting the approval from the government that okay, this system actually works. But the first part of clinical validation is really tricky. So I'll explain like how we did it for my system. So we did it in two ways. In the first part, we actually took the system to a nearby hospital. It is referred to as National University Hospital, Singapore. We tested the system on 100 subjects. We tried to predict the patterns independently from a doctor. And finally, the doctor verified the patterns, and we checked how much match is there between the system and the doctor. So we achieved an accuracy of about 88%, and that is kind of okay to deploy a system. And secondly, what we did was we so we created an artificial data set of the patterns. We gave around 35 doctors worldwide. There were few from India, there were few from Singapore and US, and there were few from Canada as well. So we asked the doctors to annotate or diagnose the disease based on a particular set of features, and then we used the features in our system, and we did the same procedure. And finally, when we compared the performance of my system with about 35 doctors, the system typically performed better than 30 of the doctors. So that's how we validated the system. Now again, there is another issue with this one, the social acceptance and the performance. So even if we say that we have achieved 88%, and that is enough to get a government approval to deploy the system. But on the longer run, we cannot guarantee that the system will work 100% on all the subjects. So from a commercial point of view, it is okay to deploy the system and get some revenue. But from an ethical point of view, it's still an open question. There is no typical answer for it. I hope that
One more thing. Even if you had mentioned that you had trialed it with 100 subjects, so
yeah.
suppose if there is any possibility that if the parameters can be varied with the ages also, then the prediction can be sometimes it will give a wrong prediction. Is there any chance for that? Whether you have done it with different age groups or you have done with only 100 subjects?
Okay, so the system is kind of a adaptive system. So it takes in all the inputs. So not only your brain signals, it also takes your other information like the medicines you are taking, your age, gender, maybe your if you are an alcoholic, whether you are taking some other treatment. So it takes all the inputs and then creates the prediction. So it's an adaptive system. It's not a clear-cut system which only depends on the brain signals.
So, is there any particular computer language you can suggest which can help us learn AI?
Yeah, so that's why I mentioned. So the best two platforms are TensorFlow and PyTorch, and all these platforms could be deployed in Python. So C programming is a more machine language, so most of the companies follow C language. And if you are using something like the MATLAB or Octave in Ubuntu, so those are more user friendly, but then they cannot be used for deploying a product. So now Python, it's again an open source platform. It's gaining momentum, especially since the AI platforms such as TensorFlow and PyTorch is in Python. So Python is the language of future. You should try out that.
So one more thing, sir.
Yeah.
What exactly the format of dataset you have been loaded into the for learning process? Whether it's a Excel data or means sometimes for maybe face recognition we have to depend upon images. For here
Yeah.
in your case, what exactly the data has been given as the input?
So in my work, we had multimodal data. Multimodal in the sense different types of data. So one modality was the brain signals. So that is kind of a time series signal. And then secondly, we had age, gender, etc. So those are like character, or I would say character based data or individual specific data. And then we also had some additional information such as the heart signals. That's again a time series, but then it's different. It's a different modality. And we also had some data related to video monitoring. So while you are performing an EEG recording, in some of the hospitals they might record your video as well. So in some, our system is capable of using all the types of data, and using all these types of data, we try to uh, find the best prediction for a particular patient. Yep.
Yeah, thank you, sir. Thank you.
Dr. John, we have a quest. We have some questions in the chat box.
Okay.
Dr. Renuka TK has asked, now a humanoid is given a citizenship, isn't it? So to identify humanoids from human beings while doing online transactions, AI itself will have to suggest new methods.
Okay. So that's the trickiest part. So that comes in the ethics. When I mentioned about ethics, so I think you can read more about it. It's a tricky part. So to remove AI, we are again using AI. So the corporates have suggested that solution, but it will never work out. So even if we deploy a new AI to do the problem, to solve the problems of the current AI, then again in future the deployed AI will have some other issues. So that's how technology works. So then for that we don't have an answer.
Hello,
Yep.
sir.
Go on.
In machine learning,
Yeah.
if we consider the example of a car,
Yeah.
we used to collect a lot of data about car and train the machine in order to get the desired output.
Yeah.
So as you said in CNN also, we do the same. So are they related to each other?
Come again. Related means you are saying like is human
There is
learning related to CNN learning?
no, in both we use to collect data and train. So are they related?
You mean CNN learning versus what is the thing we are trying to compare?
Machine learning.
Oh, okay. So you are asking the difference between machine learning and deep learning. Am I correct?
Yes, sir. Yes.
Uh, so so AI started first, then machine learning came, and recently the deep learning techniques came. So deep learning technique is a subset of machine learning, and both machine learning and deep learning are subsets of AI. So previously, in the real world, then the size of the data sets were limited. Even now, it's limited. But in certain things, like for image recognition or object recognition, since we have the social media, we have millions and millions of data to train. So once we started getting millions and millions of data, the deep learning systems came into existence, and they showed higher potential and more performance. So if the data set is limited, let's say, especially the medical data. So if you want to see the medical data of patients who underwent heart surgery or epilepsy surgery, it will be, you cannot get millions and millions of data. So when the data set is limited, the machine learning systems, or you can call them traditional systems, they tend to perform better than deep learning systems. And when you have higher data, higher quality and quantity of data, the deep learning systems will perform better. So till now, we don't know how much data we need to train a deep learning network. But the rule of thumb which we follow today is like, if you have kind of maybe around 1,000 data points, below 1,000 data points, or maybe below 10,000 data points, you can typically deploy a machine learning technique. And if you have more than 1 lakh or more, you can typically use a deep learning technique. Is that okay? Yep.
Yes, sir. Okay, thank you.
Hello, sir.
Yep.
Sir, in your opinion, how will AI impact application development?
So can you be a little bit more specific about the application? Like give an example or something?
It can be anything.
Oh, okay. So currently, it's not like how AI is going to impact. AI has already impacted all the applications. So the prime thing, what is going to come is unemployment. And in the sense, like all the routine jobs and the repetitive jobs will, especially in the manufacturing field, it will be taken up by the AI. So even the diagnosis, monitoring, and in the healthcare field, and even if you speak about autonomous cars, the jobs like driving a car, etc., all those jobs which are a little bit more repetitive will be taken up by the AI systems. And as a solution to this, you need to upskill yourselves, and you need to be the ones who create such AI platforms. And regarding the ease of applications, definitely AI has already made our lives much more easier. So easier in the sense, if you search Google, you can get all the information what you need, and it's very easy. So even if you don't know what keywords to key in, the Google is ready to help you with the suggestions. And another impact is like, maybe I'm not sure, maybe most of you might be using something like the Google Assistant or Siri or the Amazon Alexa. So you just need to sit on your chair and say, "Hey Alexa, just turn on the fan," and it switches on the fan. So technology has advanced up to that level. Even you can do some bookings. You can just say, "Hey Alexa, just book me a flight ticket from this to this." So you don't need to do anything. This will kind of make us lazy, but then it has made our lives much more easier. So it has already impacted the human life so far. In India, the impacts are still coming, I would say, but in especially the Western countries, especially in America and Singapore, it's already a complete digitalized society. Yeah.
Sir, Abin Shahji has put in a YouTube comment. So, what recommendation would you give to CEOs who haven't started looking into AI yet?
Okay. So the answer for it is simple: be responsible. So we should be aware of what we are creating. So as in the example where I showed the business model of the corporates, they were only motivated towards profit or revenue. And we cannot blame them. That's human psychology. So if you are trying to do a startup, the motivation of the startup will be profit or income. So you can deploy the AI models, but you should take the accountability and responsibility of what it leads to, its effects on the newer generation or on anything, the effects on the environment, newer generation, humans, etc. You should be responsible for it. That's the thing.
Hello, sir.
Yeah.
Sir, there are like different kinds of network like ANN, CNN, and RNN.
Yeah.
So, all these are interconnected or they are used for different applications? Can you just tell me something?
So as I have answered one of the previous questions, I forgot who was it was. Um, so initially AI was there, then the machine learning techniques came, and as the size of data grew, deep learning techniques came. So ANN, or the artificial neural network, it belongs to the machine learning field. And so once we have more data, the CNNs came. So CNN belongs to the deep learning category. So the major difference is so both are AI techniques, or you can say both are machine learning techniques. But then if you have limited size of data, you can deploy an ANN. If you have higher data size, you can go with a CNN. So if it is like saying you should deploy a ANN when you have less quantity of data, and so if you have less quantity of data and you try to deploy a CNN, it won't give you performance. So that's the situation. So if the size of data is low, ANN will give you the performance, and if the data size is high, CNN will give you the performance. Yeah, that's the difference.
Okay, thank you, sir.
Further questions can be mailed into Dr. John's mail ID. It will be posted in the chat box.
Okay. Yeah.
Um, this was a very informative and an interactive session. We're living in a critical golden hour for humanity where artificial intelligence intervention stands the best chance in today's scenario. Dr. John, it was a very intelligent session that we had just now. Now, for some lighter moments, what inspired you to research on a topic as complex as this? Any books, movies that ignited these thoughts?
So initially, so I did my undergraduate studies in NIT Calicut. So while I was studying there, I was not a high achieving student. I was just an average student. I even had a lot of backlogs, and I think currently I think Dr. Rajiv sir, he is the HOD of your electrical and electronic department. I think he had taught me once, and that was fortunately one of the subjects I had a backlog. So I think he might be here. So that's my experience. So even though I was not a high achieving student in terms of marks, I was always passionate about like developing something that could impact the society. And also I wanted to do something related to the biomedical field. So AA was not in my plan at that point of time. So then I started applying to foreign universities, and fortunately I was able to get the research scholarship at NTU. So I had a few more other opportunities, but then when so I am working under Prof. Justin Dowells. So he was mainly focusing on traditional like detection techniques to diagnose epilepsy, as I mentioned in my slides. So here, initially, we were not planning to deploy AI systems due to its explainability, but then we started with the traditional techniques like clustering or artificial neural networks or the traditional machine learning models to develop an automated systems. And then it was during, I think, the AI boom came in about 2010, between 2010 to 2015. And then like all the papers or all the research published in the literature were more towards AI based systems. That is where like we started developing our system based on AI models in about 2016, and we found that the AI system, our dataset was not very big. It had only about 20,000 data points, and we found that the AI systems, even though the dataset was slightly smaller, it could give better performance, and it was performing similar to the clinical doctors or even better than them. So then I got fascinated about AI, and then I started exploring more methods in AI, and that's how I ended up in like developing a patented system which is being commercialized now. So there were a lot of ups and downs. Sometimes there were times when the AI model gave no meaning, and we had to dig up and spend a lot of times in understanding the AI model. We need to check for the clinical validity of the model. It was a tough time, and finally we made it. So now in future as well, like I'm going to Canada. So the main focus will be on aiding the clinicians with epilepsy surgery. But then we will be using AI as a tool. So I also am a bit concerned about like kind of AI ethically. So I typically use them as tools, and I don't give complete control to the AI to decide what it has to do. It's kind of a controlled environment what I'm working in now. Yeah, I think that's more of like an experience.
During your studies and your professional journey, you might have faced several hurdles. So, can you name some and how were you able to overcome such downsides and keep yourself motivated?
Okay, so that's a difficult question. So it was a long journey. So I did my PhD just after my bachelor's life. So it was like, so usually the step is during you enjoy a lot during your bachelor studies, then you do a master studies, and that's when you get to know more about research, how it has to be done, and you also learn something like working alone in the sense it won't be a team. You have to be motivated from within, and you need to progress up. So that typical learning happens during your master's period. But there could be some students who are highly motivated during their bachelor studies as well. So I enjoyed a lot during my bachelor studies. I studies were there, but then we did everything as a team. So when I came here in PhD, the first thing I faced was loneliness. So I need to generate my own motivation, and I need to push up. So if you're a PhD student or a master student, you might get some support from your team or the supervisor, but then it's not their work. So they can only give you guidelines. The research or the hard work should come from within you. So first 2 years were a little bit tough for me, but then beyond that, I was able to find some motivation from within. It was a part of like career progression, as well as that some sense that I am developing something would impact the society. And also in the third year of my PhD, we actually went to a lot of hospitals in India. We went to 3 hospitals in Bombay. We went to AIIMS Delhi, and in 2 3 hospitals in Bangalore. So we were fortunate to share our system with a lot of doctors, and they were also interested in knowing more about it. And so this kept me socially motivated, and that's how I reached up to here.
Sir, I have got one more question, but before that, please note that the link to the feedback form has been posted in the chat box. So kindly fill it up at the end of the session. Participants, please note the link to the feedback form has been posted in the chat box. Kindly fill it up at the end of the session. Okay, sir.
Yeah.
I have one more question. I couldn't tame my curiosity.
Okay.
What does Dr. John Thomas do when he's not working on a research?
Oh,
Like,
okay.
what do you do in your free time? Or do you have?
If I think I had given the link for my personal website in my slides, so you can look it up there. So I am a passionate football player. Yeah, so we actually play at the Singapore level, at the national level. I am typically focusing, like I am a, what can I say, I'm kind of a professional in five-a-side football, and we still do it, and we have won a lot of prizes at the Singapore level. So that was kind of my passion. And the second thing is I am also passionate about aquascaping. So it's kind of an aquarium, but it's where you grow a lot of plants, fishes, and it's kind of creating a natural ecosystem. So I have about 20 to 30 tanks which I have commissioned, and all of them are running fine. And that's where I spend most of my time in. Yeah, those two are my main hobbies.
Thank you, sir. Thank you.
Yeah.
We've just walked through Dr. John's life.
kindly note the feedback form, and Dr. John's mail ID has been posted on the in the chat box. Please fill it, and further queries can be sent to his mail ID. Now over to Joel.
Thank you, sir. Thank you so much. Thank you, Lisa, and thank you, Nirmal. Thank you, sir. Once again. And now let's invite Vice Principal V.D. John, sir, for the vote of thanks. Sir, please.
A very good morning to one and all. Today's resource person, eminent researcher, Dr. John Thomas from Nanyang Technological University, Singapore. Executive Director and founder of Christ College of Engineering, Reverend Father John Palekara CMI. Reverend Father Joy Payapalli, beloved Joint Director. Our Chief Mentor and Principal of the institution, Dr. Sajeev John Sir. Distinguished Professor